What's up, everybody? In this question, we have two functions, f of x equals sine x, g of x is equal to 1 over x. Both are parent functions. And we have to find a common characteristic between those two functions and then a different characteristic between the two. The different characteristic is actually easier to find than a common characteristic with these specific functions. Actually, I think the only common characteristic that both of these have is that they are both odd functions. Okay, so that one was pretty tricky to realize because sine x, if you graph it, looks like this, and 1 over x, if you graph it, looks like this. Well, with sine x, algebraically, if you remember, to algebraically prove that a function is odd, basically f of negative x has to equal negative f of x. Well, with sine x, sine of negative x is equal to negative sine x. That's actually an identity. Now, you don't have to know that specifically. You could test it out with any angle x. Sine of negative of that angle will always equal negative sine of that positive angle. But you could also see it graphically. If you remember, an odd function is rotationally symmetrical about the origin. So if we take the right portion of this graph, the portion that's to the right of the y-axis, and then rotate it, we would end up with the left portion of the graph. And if that's a little confusing to tell, another way to graphically tell whether something is an odd function is if we take the right portion of the graph, the part that is to the right of the y-axis, so this portion here, and we reflect it in both the y-axis and the x-axis, we should get the left portion. So if we take this portion of the graph, reflect it over the y-axis, we would end up getting something like this, represented by this dotted purple line. So we reflected it over the y-axis, and then if we take this dotted purple line and then reflect it over the x-axis, we would end up with this portion of the graph. So that's another way to tell if a function is odd. If you can, when you take the right portion, reflect it over the y-axis and the x-axis, you should get the left portion. So sine x is odd, and then 1 over x is odd as well. Because algebraically, give me a sec here, f of negative x equals negative f of x, right? Because f of negative x would be 1 over negative x, and then negative f of x would be negative 1 over x, and both of these are the same. You could just bring the negative up to the numerator, and then the negative is in the numerator in that one as well. And then graphically, what can happen is if you take this right side of the graph, reflect it in the y-axis, and then reflect it over the x-axis. So if we reflect it over the y-axis, we would end up with this. And then if you reflect it over the x-axis, you would end up with this. And then same thing with this one. If we reflect this over the y-axis, we would end up having, we would end up having this. Then if we reflect that over the x-axis, we would end up with this portion of the graph. So both of these are odd functions, and that's actually, I believe, the only characteristic that both of these functions share. So this one was a little tougher than this one. And then a different characteristic, well, there's so many. Perhaps 1 over x has no x-intercepts. While sine of x goes on forever, it has infinite x-intercepts. Let's call them zeros. Another thing is the end behavior. So as x approaches infinity for 1 over x, the y's approach 0. As x approaches negative infinity, the y's approach 0. Here, this function is oscillating forever. So the y values don't approach any value, so there is no set end behavior for sin x. That's another example. The ranges are different, the domains are different, so a lot of different characteristics you can mention. The tougher one was the common characteristic, because the only common characteristic between them is that they are both odd. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.